Quantum mechanics, quantum physics. This particular aspect of science has captured the attention of common people, and it has now also turned out to be an important part of technology in the form of quantum technologies. Quantum mechanics itself is a very important branch of physics. It is interesting, important, and it has plenty of applications. It is one of the most intriguing aspects of our reality, because it leads to something which is very counterintuitive and yet so critical for us to understand our observable universe. Quantum physics also has a very deep kind of connection to atomic and molecular physics, and one is always interested in knowing how does one actually probe such quantum nature of matter, especially in the form of atoms and molecules. Interestingly, this particular question has intrigued people for a very, very long period of time. And Gerhard Herzberg was at the junction of this particular revolution, which brought atomic and molecular physics into the forefront of quantum mechanics and quantum physics during its formative years. And this particular discussion is about Gerhard Herzberg, his science and his life, which is quite interesting, fascinating, and also kind of leads us to an intuition of how he really did science during times where he was pushed out of his own country, and he had to settle down in different country and did some outstanding science. What is interesting is that he not only created an important revolution in astronomy and astrophysics, but also utilized the tools of quantum mechanics to this particular principle of astronomy and astrophysics. This turned out to be an important kind of application of quantum mechanics in its formative years and furthered the horizons of this beautiful subject. So Gerhard Herzberg life actually has very clear-cut and interesting kind of parts to it. So his formative years is in Germany. He was born in 1904, and his undergraduate years were also mainly in Germany, and to a certain extent also he visited few other countries. Then postdoctoral research. Then he became an assistant professor. And as he was just starting his career, he had to move out of his country, Germany, for the reasons I'll explain later on. Then he moved to Canada. In Canada, he did some outstanding work. Then he had a short stint in the United States of America, came back to Canada, opened up one of the most important laboratories in spectroscopy in that particular era, and still holds one of the premier kind of position in spectroscopy related to atoms, molecules, and astrophysics in Ottawa. And eventually even won a Nobel Prize in 1971. And up to the final stage of his life, Herzberg contributed immensely to science. And by contributing to science, he also contributed to humanity. And let's try to understand what was the kind of stuff what he did. So his formative years, as I mentioned, started in 1904. On the Christmas day, 25th December, he was born in Hamburg, Germany. He was the youngest son of Albin and Ella Herzberg. And these were people who were having a normal life, nothing very kind of fancy. His father wanted his children to have reasonable education, just like his any kind of parent would want to have. And Gerhard was a very good student. He really showed a lot of interest in science, mainly self-motivated, because his parents were not that highly educated, but he did take up a lot of initiatives to understand science, and showed very deep interest in science, particularly in topics related to physics and astronomy. Unfortunately, when Gerhard was around 10 to 11 years, in 1915, his father passed away because of some health related issue, he could not survive. But fortunately, this did not disrupt Gerhard's education, because he was a good student and he also had reasonable support from his ecosystem through school scholarships. This is mainly because of the fact that he was a good student and he showed a lot of interest in science, and the system was supportive of him to take up some particular scholarship. During his school, he developed very deep interest in science. He did very well in his formative years. Particularly in astronomy, he showed a lot of interest, which turned out to be extremely important going forward. He was also introduced to, Bohr's atomic model, where he studied fascinating aspects of atomic transitions, of electrons inside the atom. And it always fascinated him about this particular topic of how quantum mechanical systems behave when they actually undergo some particular transition, which turned out to be an extremely important topic all throughout his career. All this, of course, further led to very good performance in school. So he showed a lot of good kind of grades, and also turned out to be very fascinated by various different topics. This also helped him to gain entry into undergraduate studies in the university, which was not very easy during that time, because it was very difficult for somebody with a humble background to get support to do science in that particular area. So initially he was extremely interested in taking up astronomy and astrophysics as his career, but unfortunately there was not much of financial support then. It's very interesting because we are talking about 1900s in Germany, and there was not much of support to do esoteric science, which actually is very important for somebody's curiosity, but there was not much of financial support to study astronomy, and he was discouraged, in fact, to take up this particular thing, because he did not come from a background which did not have a lot of money. Instead, the scope and the opportunity for engineering physics was reasonably good. So therefore, what kind of turned out to be an interesting chapter in his life was that it turned his interest from astronomy at time being towards engineering physics, and rest of it actually happened to be so important that it made a very important career for him. So all these things helped him to gain a scholarship from a large corporation, which was an industrial corporation, which helped him to take engineering physics, which brought him to Dramstem University of Technology as an undergraduate student. And Dramstem was not very far away, so he could also be in Germany and continue his education. So within the undergraduate years, which was roughly between 1924 to 28, he entered as a student of engineering physics. And as he progressed in the engineering physics and got exposed to interesting concepts, he slowly kind of, transformed into a student of basic research in physics, because there was a lot of interesting questions which was kind of asked within the university. And mind you, Germany during 1920s was a hotbed for very interesting theoretical and experimental exposition on quantum physics. And Gerhard, although came from a kind of a humble background, he actually was in the right place. Now, this is something which is very important for us to acknowledge, because sometimes people might not have a lot of money or financial support, but being in the right place at the right time helps them with certain opportunities. And this is one of the important things what Gerhard also faced during this particular time. So he joined the group of Professor Hans Rau, who himself was an experimental physicist. There was a lot of interesting stuff which was going on in his laboratory during that time. He got exposure to experimental physics. He did a lot of interesting kind of measurements related to atoms and other kind of systems. He also got exposure to quantum mechanics. This was one of the first times where he really got interested and kind of further exposed to the literature related to the research in quantum mechanics. And one of the first papers he came across was Schrodinger's quantization as an eigenvalue problem, which is one of the fundamental papers in quantum physics. He also got exposed to interesting mathematical methods in physics. For example, differential equations. He got exposed to these particular equations and their application into realistic situations, where he could understand what is really going behind that particular mathematics, and that was an important part of his education. So all this culminated into a diploma in engineering. It's kind of equivalent to BTech, so to speak. In 1927, he got this particular diploma. And the important aspect is that he did research to get this particular diploma. He worked on spectral features of hydrogen, mainly on the Balmer series in the ionization limit related to the hydrogen atoms. The Balmer series is one of the very important line series which we come across when we study hydrogen atom, especially students who have studied physics, or even that matter, even in school education actually teaches Lyman-Balmer lines of hydrogen, and that's one of the first windows to quantum mechanics, because that's how the observations were made, including in the astronomical situations, and later adapted and also kind of came into the foray of mainstream physics. So during this undergraduate years, he published 3 papers. So he was a very, very kind of motivated student. And those papers included not only just a hydrogen atom, but also it included some very interesting questions of hydrogen molecule, and also the possibility of H3, where there are 3 atoms of hydrogen coming together, and what are the kind of postulates related to that. That is something he was also interested in. So in 1928, he further pursued this particular area of research and went on to get a Doctor of Engineering. And his thesis was related to the afterglow of nitrogen and spectral features of nitrogen molecule and ionic molecular nitrogen, which actually had very interesting kind of connotation to understanding perturbation theory of quantum mechanics. This led to further interest in physics, and it also got him a great exposure, which means that it also motivated him to do further research as a postdoctoral researcher. So if you are in Germany in late 1920s, you would always be interested in going to Göttingen. So in 1928, after getting very good exposure and doing productive Doctor of Philosophy, in this particular case Doctor of Engineering, Gerhard moved to Göttingen as a postdoc for two years, and he had a very interesting exposure during that time. The first year, he worked with the great Max Born, mainly related to theoretical problems in quantum physics. He also got to know more about perturbation theory and other aspects of quantum mechanics. He also worked simultaneously on problems associated with the dissociation of molecules. Especially one of the molecules he was very interested in was oxygen, and how oxygen molecule dissociates and what are the dissociation energies related to the oxygen molecules. This was one of the very interesting questions here. He was very, very motivated to address. Simultaneously, this was also a time where Raman effect was already in the publication stage. Raman already had published few papers. So Gerhard, as a young postdoc, also was interested in interpretation of rotational Raman spectra of nitrogen molecules, which itself was a very interesting aspect, because during that particular time, there was not much of kind of experimental evidence for neutrons. We are talking about 1928, 29 or so. So when Gerhard observed the spectral lines of rotational Raman spectra of nitrogen molecules, the even lines were turned out to be stronger compared to the odd lines. And this was a question they were trying to interpret and address what really is happening there. So what it indicated was that nitrogen nuclei essentially obeys Bose-Einstein statistics, which we now know. And contrary to the prevailing theory, this particular observation actually showed that the nitrogen nuclei obeyed Bose statistics. Again, I need to emphasize that neutron was yet to be discovered, so the information on constituents of nucleus was not very clear, and what really gave rise to this particular lines was not very trivial to address. But this was one of the very interesting cases where a spectroscopic investigation led to an indirect clue of the fact that there is some specific kind of bosonic kind of nature to the nuclei of nitrogen molecules, and therefore in order to interpret that, one will have to actually use Bose statistics. And if you use Bose statistics, it means that there is certain kind of spin associated with that particular nuclei, and therefore one cannot just make them up only with protons. One needs to also have some specific kind of elements like neutrons, which will take care of this particular structure, and it's a very fascinating kind of piece of work. In the second year, when he was a postdoctoral researcher, he worked with James Franck. James Franck was a very renowned experimental physicist in Germany. During that particular time, Gerhard worked on absorption spectra, UV absorption spectra of methyl halides, which is kind of a compound molecule. And this gave one of the first kind of exposures to polyatomic molecules. What is polyatomic molecules? These are molecules which contain more than one atom, and therefore they represent a complex system, and yet they obey quantum mechanical rules. And this gives rise to kind of an intuition of how multi-particle systems work at the quantum realm. And studying polyatomic molecules happened to be one of the most important kind of ventures in molecular quantum mechanics. So in Göttingen, when he was a postdoc, he also got exposure and also made friendship with some of the very well-known figures in quantum physics and also mathematical physics. E.P. Wigner, Marie Goppe-Mayer, Victor Vyskov. There were so many other people whom he developed friendship with. He also met in James Franck's lab Louis Oettinger. Louis actually turned out to be his future wife, and he married her in 1929. It was in Göttingen also the occasion at which he really got interested in writing a series of books. All this started actually as a lecture series, because Herzberg went on to write some outstanding books related to molecular quantum mechanics, and this was one of the first kind of occasions where he gave these lectures, and those lectures turned out to be outstanding expositions on molecular spectroscopy, and he ended up writing 4 to 5 books, which is now considered as one of the most important kind of literature on molecular spectroscopy. They also are considered as kind of encyclopedia of molecular spectroscopy, especially at the formative years, where he collected the spectra of all these molecules, and it turned out to be very fascinating. While at Göttingen, he also worked on Hund's molecular orbital theory, where the concept of bonding and antibonding was still in the formative years. So this is one of the first occasions he also kind of makes a connection to physical chemistry, because quantum physics, molecular spectroscopy, quantum chemistry, physical chemistry. This is a very beautiful kind of connective chain in physics and chemistry, and there is an interesting continuum across this. Generally, when we talk about physics and chemistry, we tend to actually separate them as specific kind of disciplines of science. But when it comes to quantum mechanics, this boundary is not very clear. That is something which is very fascinating about quantum physics and quantum chemistry, so to speak, because it only matters about how many systems or how many particles are there in this quantum system. And as you increase the complexity, you make this transition from quantum physics to quantum chemistry. and that boundary is again not very very kind of hard and strong, and one actually can learn a lot from both the sides of this particular viewpoint. During this time, when he was a postdoctoral researcher, he also was interacting with Leonard Jones. Leonard Jones was a professor at University of Bristol who was visiting Göttingen, and he came to know about these kind of interesting hypotheses what Gerhard Herzberg was doing. Mind you, Herzberg was an experimentalist, but who also had very good kind of handle over quantum theory, and he could connect the experiments to theory. This is actually a remarkable kind of intuition to develop, especially in the formative years, which means that you really become a very important person who can give intuition in both this particular stream, and that is a very critical aspect of it. So Leonard Jones invited him to Bristol to spend some time and do some research work in his laboratory. So he went there during this 1928 to 30 period, and he worked on various different molecular systems like phosphorus and nitrogen, C2H2 and CH2O, and these kind of molecules were some of the ones he really got interested about. He was mainly interested in the pre-dissociation of molecules, and this particular pre-dissociation aspect, as I mentioned, which started his postdoctoral career, turned out to be very fruitful because it also kind of brought him into the forefront of the quantum kind of problems during that particular time, contemporary research problems, and he gained a reputation as an outstanding spectroscopist who could also interpret results, connect the observations to the abstract kind of theories which were evolving during that particular time. And this is a very important thing even in physics today, because anybody who would be able to interpret experiments, do experiments, and actually connect them to abstract ideas are very useful on either side of the spectrum, and therefore they can bring in new intuition and also kind of create links between these two aspects. And Herzberg was one of the person of that kind. He also made friends with English academics during that particular time, and it turned out to be very important later on because life was to change for both good and also turbulent going forward. Now, during this particular period, Herzberg was also thinking about coming back to his home country, which was Germany. So he got a job in the name of private docent. It is kind of a position which is somewhere in between a postdoctoral researcher and an assistant professor. So you will still join a group, but you will have some bit of independence in doing your own research. So when he was at Bristol, he already actually was completing his habilitation program, and this helped him to move back to Dramsden, where he started as a private docent, and he started building spectrometers during that particular time. Grating spectrometers were still evolving, and Herzberg had got very good exposure about this in Göttingen with James Franck. So he started building these instruments, and he also started getting a lot of invitations to give talks and various other things. So this is also a time where he started his collaboration with Edward Teller on polyatomic molecules. Herzberg-Teller rules actually are very famous now, but this was a time in 1930s, early 1930s, when he is trying to kind of initiate collaboration with Herzberg-Teller. So in 1931, after seeing his progress in the way he's trying to build his group, Hans Rau, the former professor with whom he worked, takes him as an assistant professor within his group. Because in private docent, you are actually doing a work which is slightly more kind of freelance, so to speak. Whereas in assistant professorship, you have a specific kind of a salary from the university. So therefore, your career is slightly more stable during that time. So, which gives him an opportunity to supervise students and postdocs. And this is also one of the first times he really takes his leap of combining his interest in molecular spectroscopy with astronomy problems, because with the emerging photography technique, he starts recording solar spectral signatures. This is one of the first kind of connections he tries to make. And he also starts working on diatomic molecules, which are heteromolecular in nature. What do you mean by that? For example, you can have a HCl molecule, one hydrogen and one chlorine atom in a molecule, which means that you now have hydrogen and chlorine, which are two different kind of atoms combining to form a molecule. So they are heteromolecular, which means that they actually are heteroatomic in nature. Therefore, you also have different atoms constituting this particular molecule. And they are very important because they form our everyday life in various different situations. And understanding them through spectroscopy and through quantum physics is very, very important. This also brought him to the foray of polyatomic molecules, where there are many atoms in the molecules, and they give more complex kind of spectral features, and interpreting them is very, very critical. So his lab is now turning out to be a very kind of productive lab in exploration of these molecular spectra, understanding the molecular structure through the spectral signatures, and therefore it attracts a lot of visitors across the world, from US Robert Millikan, Jenkins of the fame of the Jenkins and White, and various other people start actually coming to this particular place. It also brings another person from Canada. The name of the professor is John Spinks. He was at the University of Saskatoon in Canada. He spends a year on his sabbatical because he has kind of got exposure to the fact that Herzberg is really doing some outstanding molecular spectroscopy, which has deep connection to quantum physics, but also it is turning out to be an extremely important kind of viewpoint for physical chemistry people. John Spinks was a chemist, so he wanted to get exposure, and he came to Germany to do his sabbatical research with Gerhard Herzberg. This is also a time around 1933 or so. Hitler comes into power. Adolf Hitler comes into power. Germany tends to gravitate more towards Nazism, and Louise, the wife of Gerhard Herzberg, happens to be a Jewish person. So she is actually of Jewish origin. Herzberg himself was not Jewish, but Louise, his wife, Louise Herzberg, was a Jewish person, and therefore it becomes untenable for them to live in Germany. It is a very kind of unfortunate situation where they are not able to now, go ahead and just execute their daily research and work without the interruption from the Nazi government, which is present there. So Herzberg obviously is now thinking about moving out of Germany. So he's thinking about how he could actually go out of that particular place where he can actually settle down. US was one of the options, but somehow the opportunities in US turned out to be not very, very welcoming for him. So due to his former contact of John Spinks, whom I mentioned about, Gerhard got a visiting professor in the University of Saskatchewan in Saskatoon in Canada. And in 1935, he and his family moves out of Germany to this particular place in Canada. This brings him to Canada, which for further of his lifetime turns out to be an important place where he does his research, and eventually he becomes a Canadian, and that place gives him everything what he wanted, and he settles down there eventually. It also brings him to this University of Saskatchewan. So he spends 10 years in that particular university from 1935 to 45. It's a small university. It's not a very big place, but Gerhard joined the physics department as a visiting professor to begin with. The main program during that particular time was also a master's program, which means that he's really training undergraduate students to kind of become researchers. It's kind of in between undergraduate and a PhD student. So therefore, it's kind of formative years for them to really go ahead and learn new things. So he taught many courses, including basic physics and atomic and molecular physics. What is interesting is he is very surprised by the quality of the students, what he's getting. It is turning out to be very high. He has excellent kind of, rapport with these students. They're all young, very enthusiastic, and want to learn this emerging topic of quantum mechanics. And this is also a time where his book Atomic Spectrum and various aspects related to atomic spectroscopy is translated. Earlier he would have written these books in German. In 1937 these books get translated into English, and simultaneously he's also writing book on diatomic molecules, and he completes those books during that time. In the research front, spectroscopically he's now starting to show very interesting aspects related to the length of single bonds. For example, carbon-carbon atom single bonds. He shows that it depends on the adjacent atoms which are present in the CC kind of structure. So if you have a C and a C carbon atom, it depends on what are the other atoms which are present around these particular carbon atoms. And therefore, it becomes a very critical way of looking at this kind of structural aspect of it. So, it also brings him to the work on the single and double bond, which continues for a significant period of time. During this particular time, he gets a lot of invitations from US and Canada for conferences, and he visits various different places. 1941, Yerkes Observatory in Chicago invites him to discuss about some specific absorption spectral lines of distant stars. Because the spectral lines which are emerging from the stars actually have some very interesting characteristic absorption spectrum, and Herzberg was undoubtedly one of the experts in the spectral line signatures and interpretations. Obviously, there is no other person who can be better than him to really, interpret them. So Herzberg, in collaboration with Teller, predict for the first time the possible origin of these spectral lines in distant stars to be molecular in nature, especially the CH+, which is essentially a kind of a ionic kind of part of the molecule, as a possible origin for such kind of spectral signatures. So Herzberg verifies this in the laboratory. See, this is a very interesting aspect. They observe things out there very, very far away in stars. Some spectral signatures are captured in an observatory, and those lines actually are taken from the stars observation and then matched with an experimental observation in a laboratory. And this matching is very important because in laboratory situations you have everything under your control. So you would be knowing what is the condition in which these lines emerge. So by knowing the origin of these lines from the atoms and molecules which are there in the lab and looking at those lines, you make a matching between the spectral lines in the star and the spectral lines in the laboratory. This was the first time a molecular ion was identified in the interstellar medium. That's a remarkable achievement, right? Because here you have some particular spectral line which was captured in an observatory from a star, and you are able to identify what that particular spectral line is by connecting that to an experimental observation inside the laboratory. This is the power of, verification in science, because you do an observation which is totally out of your reach in terms of the control, but you set up an experiment to do a controlled experiment to know what is the signature which is arising due to that particular process. It also has very interesting connection to free radicals in comets, because one can also now go on to study such kind of systems. And Herzberg's group was very, very active in this particular context by also, recruiting many master students. He kind of supervised about 10 master students during this particular period. And this was also a war era. Second World War was at its peak. And he also was actually contacted by the American kind of administration to interpret certain spectral lines in explosives. Of course, these are all information which is still not very, very readily available. But whatever literature is available, it says that Herzberg did help to interpret certain spectral features, although he directly did not actually participate in any of the war efforts per se. To relax during that particular time, Herzberg also started taking singing lessons, and he actually did show interest in arts and other form. And this was some kind of a relaxation process what he had during that particular time. It's kind of very, very fascinating to see that amidst all these things, he's still actually trying to keep a kind of a positive outlook in his life. Now, having seen this amazing ability for interpretation of spectral lines which are of astronomical origin, Yerkes Observatory gets really excited and invites Herzberg as a professor in the Yerkes Observatory to set up a spectroscopy lab. This was 1945 to around 1948. So during this particular time, he accepts the position. He accepts the offer as an associate professor, and then as a professor of spectroscopy. So in September 1945, he moves to US and he stays there for about 3 years or so. During this particular time, he also befriends very famous people like Subramaniam Chandrasekhar, who is also associated with that particular observatory, Kuiper of the Kuiper's belt, and there are various different people. With Chandra, he develops a very strong kind of association and friendship, which lasts throughout his life, and he also collaborates with him on certain aspects. He builds a 22-meter long spectroscopic cell to emulate planetary atmosphere. You need a very long column of gas to really take your light through that particular chamber and do spectroscopic analysis. And mind you, this is all in the era before lasers, so this was not very trivial to do. So he builds a 22-meter long spectroscopic cell to emulate planetary atmosphere. So they also collect absorption spectra of diatomic and polyatomic molecules of astrophysical interest. So molecules like oxygen, carbon monoxide, nitrogen monoxide, various different CH4, CHF3 and CH3CF3. These are the kind of complex molecules which they go on to study extensively. And he also had excellent assistants during that particular time, including Indian students. SP Sinha from Patna University, who later came back to India and also established certain interesting things. R. Narahari Rao. These are some of the people who also worked with him. And one of the main achievements during this particular time is the observation of the quadrupolar spectrum of hydrogen, which turned out to be an important kind of observation in the astrophysics and astronomy community. Only after 12 years since that observation, the quadrupolar spectrum of hydrogen molecule was observed in atmospheres of Jupiter and Uranus. So that particular observation in the laboratory situation was used as a benchmark to verify the gaseous elements in outer atmospheres of planets like Jupiter and other kind of bodies. Although the research was very interesting during this time, he and his wife somehow missed the interaction with chemists, humanities people, and generally the atmosphere in Canada. They were already used to Canada for more than 10 years. So they really felt that the ecosystem in US was slightly more kind of constraining them. So in that way, he and his wife were eager to go back to Canada. So this particular aspect is not that well kind of documented, but generally speaking, he probably had more inclination towards Canada than America, which is quite interesting and important to note in this in his biography. So during that particular time, National Research Council of Canada in Ottawa made an offer to him to become a principal research officer, And in 1948, Gerhard readily accepts that particular offer. This actually brings him to this NRC, National Research Council, and he spends now very long period from 1948 to 1994, kind of very extended period of time in this particular place. It had good funding, large lab space, sufficient staff. Also, it gets excellent equipment due to the war era. You see, that is also a time where North America is already kind of developing a lot of instrumentation, etc. And he sets up this state-of-the-art molecular spectroscopy in this particular time. And he becomes the director of Applied Physics Division, where he is this director of this particular place from 1949 to 55. And in that particular lab, he has an excellent principal assistant who stays with him for more than 33 years. And his name is Alex Douglas. And Herzberg always kind of, acknowledges his contribution all throughout his career, and in various different talks he has given, he has told about him. This is also a time where they are building high resolution spectroscopy at various different wavelengths, all the way from UV to radio waves. Flash photolysis techniques are coming up. Spin and magnetic moments are being kind of explored in the context of nuclear magnetic resonance. And the coupling between electronic degree of freedom and nuclear degree of freedom is also extensively studied. So the excited states of atoms, molecules, which are of interest to astrophysics, is also a topic of interest in this laboratory. So you can see he's really, exploring various different aspects with one viewpoint of understanding the quantum physics of atoms and molecules. And you can see that it is having very important ramification far beyond the laboratory situation all the way to astrophysical situations. So this is also a time where they are studying pressure-induced absorption, because this is an important problem to understand the outer atmosphere of Jupiter and other kind of planets. Another important kind of area they start in this particular time is to study so-called free radicals, where particularly the methylene molecule and methyl molecule, which are CH2 and CH3 molecules, are spectroscopically studied, and the CH bond lengths and the angle between HC and H is now kind of indirectly kind of measured through the spectroscopic signatures. That is the power of spectroscopy, because you would be able to now extract meaningful information from the spectral lines, and you can back calculate these lengths and other kind of systems using quantum mechanical models. Eventually, this kind of free radical research becomes very important. It really creates a revolution, because this is the first time where you have a very strong kind of tendency of understanding these principles of free radicals in a spectroscopic kind of viewpoint, and gives a deep insight to molecular spectra and structure. And therefore, 1971, the Nobel Prize is given to Gerhard Herzberg, which turns out to be a befitting kind of honor for him for his lifelong contribution to this outstanding work. The citation itself reads as for contribution to the knowledge of electronic structure and geometry of molecules, particularly free radicals. That is the main citation of the Nobel Prize. So, about 30 free radicals were studied by Herzberg and his group, which turned out to be an outstanding kind of achievement by itself. And molecular ions, which happen to also have deep implication in stellar atmosphere, etc., etc. These all things also made, or rather created a strong foundation for a subfield in astrophysics, which is called as molecular astrophysics. And this also had connection to interstellar spectroscopy and astrochemistry, which is now a very important area in planetary kind of exploration, etc., etc. Even NASA, ISRO, all these agencies are very interested in these signatures of spectroscopic kind of characteristics. So this particular place where he established was a place where there were numerous postdocs and researchers who visited from all over the world. It stimulated great kind of exchange of ideas, and the environment to do research was very, very nice. And it was kind of compared to the Cavendish Laboratory in Cambridge and Bohr's Institution at Copenhagen. So it initiated also various different areas of research like low temperature physics, solid state physics, theoretical physics, plasma physics. So you can see what started as a small venture actually has turned out to be a very, very broad kind of exposition in various different areas. So all this gave them, outstanding recognition across the world, and it also encouraged and gave a platform to mentor young researchers and colleagues. It also was a place where there was a strong support for basic science and human rights, because there are many people who actually had immigrated from Europe, and therefore they formed a very strong group and had a deep understanding of how important it is for them to be in a free atmosphere, free environment to do high quality research. It also fetched Gerhard Herzberg and his colleagues various different prizes. It also was a place for great education. Herzberg himself actually continued to write these outstanding textbooks, and the famous trilogy of molecular spectra and molecular structure was also written during this particular time. Around 1995 or so, due to the old age, Herzberg could not actually do much work. That was only in the last 4 years of his life, to be very frank. So he was very active even during that particular final years. So there was also a lot of interest in spectroscopic search for rare molecules and chemical processes, especially in astronomical situations. And that was a question Herzberg was very interested. And around 1996, his kind of health deteriorated, and it seems he stopped actively kind of doing research in his office, probably because he had some Parkinson's kind of disease. And like all good things, Herzberg passed away on 3rd March 1999 due to some illness. But he lived a full and fulfilling, knowledgeable life, and that is something which is quite outstanding for us to appreciate. The achievements of Herzberg are many. He wrote, of course, 6 outstanding books. One of them is co-written. He established this great lab, a spectroscopic lab at NRC Ottawa, which even today it happens to be one of the greatest kind of organization for molecular spectroscopy and other things. In the realm of physics, he started with atomic and kind of hydrogen and helium, and then he moved to molecular hydrogen and his isotopes. He studied extensively energy levels and constants, which turned out to be extremely important to lay the foundation for atomic physics and also quantum mechanics in general. This graduated his thoughts to chemistry, and which helped him to really explore free radicals, molecules like CH2, CH3, and also triatomic hydrogen, H3. And this helped him to really explore the molecular structure and discover the spectra. So you literally are looking at the fingerprints of these particular molecules. And these fingerprints become very critical in various different situations, including astrophysical situations, because one can now capture the lab spectrum of molecular kind of ions like CH+, which turned out to have been proven of its presence in the interstellar medium later on, after the spectra was discovered. And also in comets, there are questions of presence of molecules like water and carbon, and people are interested in knowing whether these kind of molecules are present in comets. And lo and behold, the spectroscopic signatures of Herzberg was utilized to explore these kind of systems. Another fascinating aspect is the quadrupolar spectra of hydrogen. And it turns out that these quadrupolar spectra also of hydrogen molecules are present in the atmosphere of planets. So the laboratory proof was given by Herzberg, and it turned out to be an important kind of contribution. All in all, Herzberg was an outstanding scientist. He really had a very long career spanning almost to 95 years. And out of these 95 years, probably for up to the age of 90 or 92, he was very active in research. And there are some outstanding sources for you to go and explore about his life and science. One of them is the Gerhard Herzberg, An Illustrious Life in Science, by his former postdoc Boris Stoshev. I'll link the reference to that particular book, which is really worth reading. There's also a biographical memoirs of Fellows of Royal Society. The same author, Boris Stoshev, has written about this, where he gives a kind of a slightly more a limited aspect of his life and science. But it's a short read, but it is worth reading. These two sources I also have used to write an article in Resonance in journal, which I'll also link. You can have a look at it. And most of the stuff what I've discussed is from that particular article. So finally, what I want to tell is that Herzberg had very, very kind of deep and broad application of quantum physics to molecular spectroscopy and astrophysics. He contributed extensively to these areas. All along the way, he actually really learned a lot of things from various different people and did outstanding experiments, connected them to abstract concepts. And he also mentored so many people, wrote books. In that way, he had an outstanding, intellectual career. And there's a lot to learn because Herzberg did not have an easy life. He had to literally uproot himself from his German roots, and only later on, once things settled down after 1950s, it seems he visited Germany for a short time. But then his ties and his roots were all uprooted, unfortunately. But the fact that the loss of Germany was a gain of not only the North America, both in Canada and in USA, but also kind of it was a fortune of the scientific world to have Herzberg explore this wonderful array of problems, and all along the way with a smile, and all along the way with deep commitment to knowledge and humanity. So this is Pratidhwani, where we try to humanize science. I'm your host, G.V. Pawan Kumar. Until next time, bye-bye and take care.